Hi all, welcome to session 31 of Java Full Stack Made Easy. In this session, we'll be learning about Java 8 features. And one of the most powerful feature that was introduced into Java 8 is Lambda Expressions. So you'll see a lot of interview questions and a lot of usage of Lambda Expressions in future. So what exactly these Lambda Expressions are and why they were introduced into Java. So the first point about Lambda Expressions was that they were introduced into Java 8. And this Lambda expression enables functional programming and it simplifies the syntax of anonymous classes. So in this session, we will also talk about the concept of anonymous classes. Fine. So let's go ahead and begin with the concept of Lambda expression. And my previous example was related to maps and the real-time use of a map where I use the concept of libraries. So I'll close up everything that I was working on. And let's get started with the new class, and then let's see how the concept of Lambda can be introduced into our programming. Fine. So let me create a class and let's call that as Java 8. Okay, Java 8 demos. Fine. So before I directly dive deep into the concept of Lambda expressions, let's see how we can create a simple interface and how we traditionally implement it. After that, we will see how can we create a anonymous class, and then we will see how can we make use of a Lambda expression. Fine. So we will compare all these three, and you will be able to understand after comparing all of that. You will appreciate the use of Lambda expressions. Fine. So in this example itself, the Java 8 demos. So first what I will do is I will create one simple interface here. Okay, let's call it as interface, maybe something like a test interface. Okay, so this interface contains, let's say, one method, maybe a void display method, and that's it. Just one method it contains. And this class Java 8 demos, what I'll do is I'll say this class actually implements the test interface. Let's have an implementation class for that. Okay, let's not write this class. Let's consider this class as a service class for us, which will have a main method, and this will be the class that is going to implement it. So let's call this as test IMPL. So it's an implementation class for this test interface. So this will implement the test interface. Okay. So since this class is implementing that test interface, it has to override the unimplemented method, right? Then we can write this method system.out.println hello world. This is what we have done up to now, right? And then what we can actually do is we can say test interface t equals to new, the implementation class, that is test IMPL. Okay, we cannot directly create an instance of an interface, right? So we are creating it with the implementation class, and then what we can do is we can say t dot display. So yeah, that's fine. You should be able to call this display. This is public, class implements test enter, test IMPL. Okay. So display identifier expected after this token. Oh, sorry, that's because I did not implement a main method. How can we directly write these things outside a function? Alright, so let's put it inside the main method. Let's save it, and now let's run this piece of code and get the result of this display. So this is what we have done up to now. Hello world looks good, clear cut. There is an interface, there's an implementation class for the same, and then there is a service class that is creating and instantiating the interface and then calling the interface method display. So this is what we have done up to now. So I will first copy this and put this into the repository. Also I have added two more assignments into the repository, the collection assignment 2 and the collection assignment 3, which is specifically the third one is specifically focusing on the maps, second one focuses on the list, set, map and the queues. Find comparator as well as the comparable. So I encourage you to go through this and complete the assignments. Fine. So this is our session 31. So this should be day 31, right? Yes. So let's create a day 31 repository here. Demo 1. This is the normal way of doing it, right? So that's what we used to do. What I will do is in this demo itself I will add everything, or else yeah, let's create different demos for the same. So demo 1, this is the traditional approach that we have followed till now. Now what I can do is, since my implementation is only once, so why should I actually be creating a separate implementation class, right? This implementation, this method, this class is only created for this implementation. So why should I be creating a separate class and do all these things? Why not just directly create a anonymous class? So let's try and avoid this boilerplate code here. Okay, so if I remove this, I can still do something like this. The test IMPL, okay, and then directly I can do this. So which would be much more beneficial and useful if I do something like this. Let's remove this. Let's complete the main method, test IMPL. Fine. So this way what we can do is we can simply say test interface and then get a display method, system.out.println. Let's again go for a hello world, save it, and then here I can do a t.display, that will be called save it, run it now. So you can see that hello world is called once again, but what I have avoided here is I have avoided a class. An extra class is not written here. So what is happening here? What have I done here? Test interface is equal to new test interface, which we cannot do, right? We cannot create an instantiate a interface. But what is this then? See, this is basically not a instance of an interface. This is an anonymous class. So behind the scene what is happening is a class, an unnamed class is created that implements a test interface, and this is the implementation. This is that particular class. So a class is created with a without a name. An unnamed class called as the anonymous class is created, right? Classes without any name is called as the anonymous classes. So this is what an anonymous class is all about. Fine. So you can again compare this previous demo with the current demo. In the previous demo I had an extra class here. So what I did was, instead of creating class, test implementation, implements, test interface and all, here itself I created a test interface and created this entire stuff inside this itself. So you can see that. See, instead of creating that extra class, remove that extra class, and that class implementation is here. Fine. Just a new test interface and implementation. This is how anonymous classes can be created in Java. So let me put this as well into the repository. Demo 2. Fine. So now what we discussed while dealing with the Lambda expressions. So first let's just commit this, and then we will focus on the Lambda stuff. Okay, this is anonymous class, right? Now, Lambda expressions were introduced to enable functional programming and simplify the syntax of anonymous classes. So this is definitely a simplified version of what I did in the previous example. But when Lambda expressions were introduced, the Lambda expressions are actually a more simplified version of anonymous classes. Now, how can I implement a Lambda expression and make it more simplified? So let's understand that and implement it. So here I have a test interface. Then I have an anonymous class and everything. So instead of writing this new test interface now, what I will do is I'll just clean up this, right? And I will just write a Lambda expression here. Fine. And then once I write the Lambda expression, I don't need to write this override. I don't need to write this display and everything. So all of this just looks plain. Fine. So now you compare the previous example with this example. So in the previous example I have to write new test interface, and then I have to write an override, and then I have to write a display method and everything. But here with the Lambda expression I am simply writing what a Lambda expression is written like this, and then the body of that Lambda expression. That's it. Fine. And the result of this program also will be the same. Fine. Hello world. So now I'll copy this as well and put it into the repository, and let's call this as a Lambda expression. So demo 3 Lambda expression. Now what I will do is, let's take all of this. Let's take this Lambda expression and let's commit this first. Okay, so what I'll do is, let's have a notepad file, and within that let's put everything. So this is the Lambda stuff which I have created now, and then the anonymous class, and then lastly the traditional way of doing it. Fine, and let's compare each one of them and understand which one is better. That means which is more easier. All of them leads to the same thing itself. So whatever we perform there, everything does the same thing itself. Fine. So now let's compare everything. So this is the first part where we created an interface, created an implementation class, and then we have overridden the display method, and then the service class. And in the service class, with the implementation of this particular class, we are creating the instance and then calling the display method. So this is approach number 1. Fine. So many line of code. Approach number 2 is this, the anonymous class concept, where again we created an interface. And in this case, we what we did was, we actually did not create the implementation class. Fine. So we have avoided the implementation class. We have directly created an anonymous implementation class here. An anonymous class is created here. Fine. So again we have cut shorted the boilerplate code that we have to write. Now the third approach is very simple and straightforward. We have an interface, and then we directly have a Lambda expression, and we have written the method body. That's it. We have not written any anonymous class, neither we have given a method name, nor we have given any override annotation or anything. Right? So this is the magic of the concept of Lambda expressions. They were introduced to simplify the syntax of anonymous classes. So this was the syntax of an anonymous class. This particular Lambda expression simplifies this. Fine. So I hope you have now got to know the concept of Lambda expression. That means how the Lambda expressions comes into picture and where should we be using the Lambda expression. But while using the Lambda expression, one rule has to be kept in the mind. What is that? So let me tell you what is that. Okay, so Lambda expressions, they work only on the functional interface. Now what do I mean by Lambda expressions working on the functional interface? You see here, when I'm using this Lambda expression here, am I giving a method name? Which method has to be overridden? No, right? I'm not giving here as display method has to be overridden. The reason for that is I'm applying the Lambda expression on a functional interface. Now what is a functional interface? There's another annotation introduced into Java 1.8 which is called as the functional interface. A functional interface is one that has only one abstract method. Now you see on this particular interface, when I add a functional interface, it gives me no problem whatsoever. If suppose I come down to this interface and add one more method, let's say ABC method is something which I have added. The moment I add an ABC method, there you first see there is an error on that functional interface. It says invalid functional interface annotation test interface is not a functional interface. That's because a functional interface is an interface with just one abstract method. Now how many abstract methods I have here? I have 2 abstract methods. So this is not a functional interface. So if it is not a functional interface, you can see that there is an error here as well. The target type of this expression must be a functional interface. So I will give you this error as well with the target type so that you understand Lambda expressions can only be applied on functional interface, and a functional interface is one that has only one abstract method. Fine. So the target type of this expression must be a functional interface. A functional interface is one that has only one abstract method. Is one that has only one abstract method. Fine. So this will definitely give you an error. So with the description, demo for functional interface. So lambdas work only on the functional interface because in Lambda expressions we don't write the method names. So because we are not writing any method name, so there is a requirement that there should be only one single method. If there is more than one method, then Lambda expressions will not work on it. Yeah, in terms of anonymous classes, you write the method name, so anonymous classes might work there, but Lambda expressions will not work. Okay, so let me just give you an example of a anonymous class as well there. Fine. If instead of having this Lambda expression, if it was an anonymous class, then it is all fine to have more than one interface. So how do we do that? New test interface. So let's have an anonymous class. So in an anonymous class, it is all fine. So you can see that there is a system.out.println, a display method, and then this an ABC method. Fine. So if you call display, it will give display. If you call ABC, it will give ABC. So let's save it and run it. So if you call the display method, it gives you the display. If you call ABC, it will give you the ABC. So this is fine. In an anonymous class, it is all fine to have a functional or a non-functional interface. But Lambda expression works only on the functional interface. Because in an anonymous class, we do write the method names, but here we are not writing the method names, right? Okay. This is what? Anonymous class. Fine. So you should always consider this thing in, always keep this in your mind. Obviously, the Lambda expressions were introduced to simplify the syntax of anonymous class, but the Lambda expressions can only be applied on a functional interface. If the interface contains more than one abstract method, then again you have to go back to the old strategy, that is anonymous classes. So Lambda expression does not entirely replace anonymous classes. Lambda expression only makes it simple. It only simplifies the syntax of anonymous classes, especially where we have the functional interface. Okay, I hope the concept of this anonymous classes and functional interface and the Lambda expression is completely clear to you. So let's go ahead and then let's talk about the what if the interface method takes argument. Can Lambda expression takes argument or not? Okay, so let me clean up this and add a functional interface on top of this interface so that we ensure that the below interface is a functional interface so that we can apply the Lambda expressions on them. So when we have a Lambda expression, we don't need all these things, right? So it's just a Lambda expression that we have. Fine. So this is how we write the Lambda expressions, and the system.out.println display ABC and all is not required. Let's just remove that. Done. So t.display is all valid. T.abc does not exist now. So this is what the Lambda expression looked like before, right? So the demo I have given you, this is how it looks like. Now my requirement is that this display method takes some argument like the string, let's say message. Fine. So whenever I have arguments to display method, where am I going to pass those arguments here? So you can pass the arguments in this Lambda expression here itself. So what we can do is we can simply say it takes a string message, and display method, you just print that message. So whoever passes the message here, that message has to be displayed. Display hello world. So that's what I want. So let's save it and run it and see the result. So display hello world is printed. So what is happening is this display method is here, hello world, whatever you pass in here, so it goes here, and that is something which is printed. So this is how you deal with the abstract methods that take arguments. It can take one argument or it can take multiple arguments as well. So let's call this as demo 6 lambda with argument. Lambda with arguments. So looks good. Fine. Now this lambda expression, the function, the lambda that I have created, I will create one more lambda expression and slightly I will change the syntax here. You just see it. So this the display was fine. So what I will do now is once again, I'm gonna take something like this. Let's say this is a test interface 1 T1, and in the previous case I passed in the type of argument, and here I'm not passing in the type of the argument T1, and then T1.display is something which I'm calling. I save it and run this. You will see that the result is again the same. So that means passing the type of argument in the lambda expression is not mandatory, because the lambda expression is intelligent enough to understand the type because it is working on the functional interface, so it can easily understand that. Fine. So let me copy this and put it again, demo 7. Lambda. Again with arguments without type. I have definitely passed the argument, but I did not pass the type of the argument like in the above example. Here I have passed in the type as string. Here I am not passing in the type as string. So that's because the lambda understands, it's working on just one method, so it understands that the type of that argument. Fine. So let's take one more example of this functional interface where we will have a method that would take a return type. Fine. Now a abstract method would take a return type. So what I will do is I'll just call this as maybe in test interface, let's call this as converter, a currency converter thing, okay, which takes the dollar and converts that into the rupees and returns you the data. Okay, so void. Now what I want to do is, instead of having this as void, I want to give it as float. So function with a return type. Now how will we use a lambda expression on this? So let's go ahead and understand the same again. So let me clean this up so that it will be easy for us to once again understand the concept of lambda expressions. So the traditional approach would be something like test interface t equals to then the lambda expression, right? So this is what we have done, correct? This is what we generally do. So I will give some arguments here, the value, right? So it is going to be the dollar will be provided to me, and what will I do with that dollar? So I'm gonna say float, let's say result is equal to dollar into, let's say 87. That should actually give me the value, right? And then return the result. Fine. So everything looks good. Fine. So we have created a function which is returning the value. So I have written a lambda expression that returns something. A return statement is written. So let's see how can we call this stuff and print the details. So let's say we will call t dot converter and we'll pass some dollars. $10 should be 870 rupees. So either I can directly just call it inside the system.out.println, or I can take a float variable and store it inside the float variable and then print that. Okay, so I will use this approach. Float, this is the value, rupee value is equal to, then system.out.println value plus rupees. Fine. So now it should give me 870 rupees. After conversion, it should be 870 rupees converted. So we have now created what? Lambda expression that returns the value. Fine. So hopefully the syntax is again clear cut. A lambda was having a function with a return value. So that's what I have returned here. This is all possible. Or else we can even simplify this. This can be simplified. So how can I simplify that? So let me just put this first into the repository and then give you the simplified version of this as well. So this is my demo 8. Lambda with return statement. Fine. All right. So let's go here once again. I will now see, this is how I implemented this before. Now I want to make it more and more simplified. So what I can actually do is, what I want, $87 is my requirement. So I'll just cut this off from here. I'll not write anything like this. Okay, simply I will write like an expression. That's it. That's it. I don't do anything. So let's let all the other thing remains the same. Fine. Let's save it, run it, and we get the same result. 870 rupees. Fine. So now this is what? This is more and more simplified version of it, right? Much more simplified than what I had before. So let me again put this as well into the repository and see this. So I hope now you have got to know the syntax of Lambda. You can now be a bit more familiar with the Lambda expression. So demo 9, Lambda, one liner. In just one line I have done everything in the Lambda expression, right? So it automatically understands that it has to return that value itself. So no need to write a return statement and all that. It's not required at all. Fine. So let's now try and use this Lambda expression in real time. Fine. So if you remember, we spoke about something called as the comparator. Remember comparator, we created something like player jersey number sort and player name sort. If you remember these classes during the collections, we have used player name sort and player jersey sort. Let me check. Two classes I created for comparator. See whether they are there in some packages or something. So we did create sorting classes, calculator, collection, demo. Yeah, here is player jersey sort, player name sort. So if you look at this comparator actually has only one method, that is compare, right? So comparator can be considered as a functional interface, right? If you see this here, if I put my cursor on this comparator, it shows you it's a functional interface because it contains only one abstract method. So since it is a functional interface, then obviously what we can do? We can apply Lambda expression on that, right? So let's now try and use Lambda expression. That means apply Lambda expression on a comparator. So I'll remove this interface. I don't need it anymore. Functional interface, that's gone. And now what I will do is I will create a list of what? List of players. Okay, so let's create a list of player. We already have a player and we know that player has a name and a jersey number, right? And what it has? Role as well. Fine. So these are the things that are available into the player. So let's create a list of player. Let's call it as players is equal to new array list. Fine. And in this array list, I would like to add the players. So let's create the instances of player. So player is equal to new player. It has name, jersey number, and roll number, and the role. So the name, then the jersey number, and the role. Fine. So let's just give it as this. 3 players I want to have. Let's call them as player 1, 2, and 3. Let's say Virat, Rohit, and Sachin. So 3 players I have, 45, 10. Let's now perform sorting on these players, right? So let's add that to the players. Players.add, let's add all 3. player 1, 2 and 3. So now that it is a list, it maintains the order, right? But what I want is I want to perform sorting on this. So to perform sorting on this, either the player class should implement comparable or we have to write a comparator, right? So in this case, what I'm going to do is, since comparator is a functional interface, I want to use a Lambda expression on that and see how things work there. So let's see how do we do it. So collections.sort, directly I'm writing here. What collection I want to sort? I want to sort the players collection. So let's write that collection. And then the second argument should be the comparator, right? So now I'm giving the comparator as a Lambda expression. You see what I'm doing here. So I'm just using a Lambda expression, right? So while I'm using a Lambda expression here, so I will say this Lambda, the comparator takes 2 argument, right? Comparator takes 2 argument, which is of type player. And we know that in the Lambda expression, we may or may not give the type. So let's just give it as object 1 comma object 2, right? So I have written a object 1 and object 2, and we know that in Lambda we can write a return statement or we may avoid it depending upon the situation. So I'm just saying return object 1 dot get jersey number minus object 2 dot get jersey number. So by implementing this, what we have actually done is we will be able to sort this collection based on the jersey number in the ascending order, since the object 1 is used first. So let's save it, and also to check whether they are sorted or not, I'll be using a for loop player p of players. Fine, and then let's just print the p. So system.out.println p, it should be sorted based on the jersey number in ascending order. Let's save it and run it. So here you can see jersey number 10 is the first data that I'm getting, and then the jersey number 18 and jersey number 45. So this way I can use Lambda expression in real world. What I simply did was I performed the sorting and then used the Lambda expression on the same. Similarly, you can use Lambda expression on any functional interface of your choice. Fine. They can perform sorting on this, and you can use any Lambda expression. So now in the next session, what I will show you is I will show you how do you use a for each that was introduced again into Java 1.8, and also I will show you how do you make use of the method references, which is an alternative to Lambda expression. Fine. I hope you have got to know what I have done here. I've used a Lambda expression with 2 arguments, and then I'm returning jersey number minus O2 dot jersey number. So to make it in ascending order, if it is descending, O2 my dot jersey number minus O1, if I do that, it will go in the descending order sort. So I'll put this into the repository. You also try it on your collections, and this is my demo 10. Demo 10 Lambda expression with comparator. Done. Fine. Alright, so in the next in this session we talked about the Lambda expression. We have seen the Lambda expression functional interface as well. Lambda works only with the functional interface, and the functional interface is one that has only one abstract method. Lambda were introduced to simplify the usage of syntax of anonymous classes, but especially for those anonymous classes which have only one abstract method, right? That means which is used for the functional interface. Then we have seen Lambda expression, and then the method taking arguments with Lambda expression, and the method returning the value as well with the Lambda expression. Then we applied the Lambda expression on a comparator, because a comparator itself is a functional interface. So if you like in the series, do share, comment, subscribe, and encourage me to create more such video. See you in the next session.